the vast expanse of the American West, at the heart of an unforgiving desert, the Colorado River flowed untamed for thousands of years, until deep within an inaccessible canyon rose the Hoover Dam. In the 1930s, the American government embarked on the world's most audacious engineering project, a daring structure that would become the world's tallest dam, stretching 660 feet at its base and surpassing the height of the pyramids of Giza.
Some works are disproportionate, either by their size or their aesthetic quality.
A dam of this size had never been built. It was enormous. Many people said it was impossible. It would never happen.
This arched dam would be the world's largest concrete structure, an impressive technical achievement that came at a steep cost. Over nearly 5 years, 20,000 men worked on the site, with some tragically suffocating to death in the diversion tunnels or on the canyon floor. This was the grim price of meeting the brutal deadlines of this revolutionary structure.
Some would say the most ambitious in the history of civil engineering.
It broke all those records. It was the highest dam.
The unparalleled project faced unprecedented challenges. How could the Colorado River be diverted from its course in record time? How could the massive amount of concrete be produced and cured in temperatures topping 100 degrees? What was the best way to generate power for the largest cities in the southwestern United States? The dam's visionary engineers managed to reshape the geography of the desert. Through their Herculean efforts, they irrigated new farmland and brought water to Las Vegas.
It is a monumental dam that encloses one of the largest reservoirs in North America, and at that time in the world.
So this kind of puts us on this track of think big, think big.
The story of the Hoover Dam's epic construction continues to inspire engineers worldwide. But a century after its construction, the dam faces significant challenges from climate change, as rain and water shortages weaken its output. In uncertain times, what threats lie ahead for the dam and the western United States that depend on it? For the past century, Hoover Dam has supplied water for crops, cities, industries, and electrical power to the states of Nevada, Arizona, and California, making it a significant contributor to the development of a once desolate region. As an exceptional technical and aesthetic achievement, it remains one of the wonders of the 20th century industrial world. The dam's construction was made possible through cooperation between the 7 states of the Colorado River Basin and the U.S. federal government.
A visionary named Theodore Roosevelt, President of the United States of America, predicted that someday more people would live west of the Mississippi than east of the Mississippi in the U.S. He saw that the only way to make that happen was to harness water resources, to build storage and transportation facilities for water.
This inhospitable and arid region of the American West is characterized by spectacular landscapes, high mountains, deep canyons, and scorching deserts. Within flows the Colorado River, which has flowed unimpeded for thousands of years.
The southwest United States is a desert. There's not much water at all, except the Colorado River.
The Colorado River rises in the Rocky Mountains, flows through 5 states, and ends into the Gulf of California in Mexico. In the past, this mighty river used to wash away everything in its path, carving out the rock and shaping gorges in the highlands.
The Colorado River is just as wild as the deserts here.
The Colorado River is the lifeline of the American Southwest. The Colorado River flows about 2,300 kilometers long.
In the early 20th century, there were a series of floods on the Colorado River, 1905 to 1907. Massive floods that flooded and took out 100,000 acres of farmland in the Imperial Valley. By that time, it became imperative they had to do something to control the Colorado River.
The solution? Build a gigantic structure capable of holding back the Colorado River to avoid flooding, store water to irrigate the dry areas, and provide power. Electricity production surged in Los Angeles, Phoenix, and Las Vegas, allowing these cities to grow fast.
Hoover Dam represented the modern age in the United States and the future.
It really shows the power of man, a Promethean power, over the American West wilderness. It was a huge undertaking, and they knew it from the beginning.
It was approved on December 21st, 1928. Less than a year later, in October 1929, the stock market crashed. Everything was in collapse. And the dam project turned out to be this one bright spot in a very, very dark world.
The U.S. government then decided to maintain this ambitious engineering project despite the advent of the Great Depression. It was named the Boulder Canyon Project in reference to the Boulder Canyon where it was to be built. The state had to find a solution to create jobs, as 1/4 of the active population is unemployed.
It became something that personified a great effort of everybody to do something that they had control over.
The government set the objectives. 7 years to complete the dam from 1931 to 1938 with a budget of $760 million in today's dollars. They then had to find the companies capable of carrying out such a project.
Building a dam is a generational undertaking that employs tens of thousands of people for several years. And it is an industrial challenge, a remarkable industrial and technical challenge.
It was clear that there was no single construction company in the country that was capable of managing it. But there was this man named Frank Crowe. And he was an old dam worker, and he really wanted to build this dam. When he determined he was going to be the one to do it. And he then brought together what they called the six companies, or the Big Six.
A conglomerate that was able to manage all the technical and logistical aspects of the construction.
The work was going to be monumental. In order to control the Colorado River, the engineers had to meet all the challenges. The idea was to divert the river, to dry its bed, and to erect the concrete dam. The wall of the dam would allow to create the reservoir. But there was a problem. How to design a wall to withstand the extreme pressure exerted by the river's current? Building a simple straight wall is not enough. It might collapse under the force of the water of the river. The concrete will be damaged upstream, which will put stress on the wall downstream. Cracks can appear and the dam could fail. Hoover's engineers found the solution and opted to create an arch gravity dam.
So we call this massive dam a gravity arch because it performs both as a gravity dam, which is a dam that's thick at the base, holds back water pressure with just mass, and it has the strength of an arch, which holds back water from reinforcing the forces on the dam pushed to the canyon walls.
It has the double safety of being heavy, robust, massive, and also of transferring part of the weight to the edges.
But there were other issues. Now they had to set up the site. How do you transport men and materials to a barren desert? How do you work under extreme heat in the summer? How do you dig this rock, which seems so solid, with the work of hands?
It seemed crazy, and the project had been continually postponed because they thought it would be impossible.
This is big. That was huge at the time.
The dam was to be built between Arizona and Nevada. The Colorado River forms a natural border between the two southwestern states. Construction was to begin in March 1931. Initially, Boulder Canyon was designated as the site for the dam.
Then they discovered the geology was not as good. They moved 6 miles downstream to a place called Black Canyon.
One of the advantages of Black Canyon is the rock. It's dolomite rock. It's very hard volcanic rock. The tougher the rock in the canyon, the better of a quality structure we can build. But the second big advantage, it's often overlooked. The Boulder Canyon site would not have stored as much water because the body of water that you can see behind me, that would not exist in the Boulder Canyon site. You got twice the water.
They changed the site, but they didn't change the name. It's always been called the Boulder Dam until it was changed to Hoover Dam later.
The Black Canyon site provided optimal stability. It also allowed an economy of materials because it is narrower than Boulder Canyon. But accessing it was challenging. The canyon plunges nearly 2,000 feet and is nearly 1,150 feet wide.
You're on this little postage stamp at the bottom of a deep canyon. You can look down there, but you can't even get down there when you come look at the site. And they went by boat. There was no access.
Accessibility is the real challenge. You have to keep in mind that this is a place where there's absolutely nothing.
And so, first of all, the objective was to build an access to reach this site in the middle of the desert. An entire infrastructure had to be put in place before construction could even begin, by bringing electricity to the site and build roads and railroads from Southern California to transport the materials and workers needed.
Frank Crowe was a man whose nickname was Hurry Up Crowe, because he wanted to get things done right now. So the 6 companies worked out a deal with Frank Crowe that if he brought the project in on budget and on time, he would get a bonus of $300,000, which is equivalent today to about $6.5 million.
In order to go as fast as possible, Frank Crowe was going to need manpower, a lot of manpower. At the height of the work, 5,000 workers from all over North America were working on the site every day in inhuman conditions.
Initially, there were close to 5,000 people who showed up in southern Nevada with no place to live.
People literally lived in tents down by the river. A famous location was called Ragtown, and that's where the workers stayed, some of them more than a year, waiting for the actual hiring and jobs to start.
The promised housing was late, and it is in a gigantic slum that the adventure began. But soon summer arrived, and with it, infernal temperatures. That year, they reached 118 degrees in the shade, but it didn't slow down Frank Crowe in his momentum. He launched the first phase. The Colorado River had to be diverted.
To build a dam, you have to temporarily divert the course of the river. In other words, you have to make the water pass elsewhere than in its usual stream bed.
The river had to be moved.
That plan allows the construction site to be dried up.
The first and riskiest part of the project was building 4 diversion tunnels through the canyon walls.
56-foot diameter, 2 on each side of the river. The total length of all 4 tunnels is 16,000 feet.
The drilling of the tunnels began in June 1931. The workers had to dig by hand and clear the ground, starting at the bottom. But quickly, the situation became unbearable because of the summer heat. A man died every 2 days.
In the tunnels, you have the worst of the worst.
Over 120 degrees every day. And digging and blasting in those tunnels, it got even hotter inside. Some people say 140 degrees Fahrenheit.
The tunnels had poor ventilation, so as we went deeper into the rock, we moved further away from natural sources of airflow. As a result, temperatures rose to very high levels.
The ventilation was bad, the extreme heat, and moving vehicles constantly, 24 hours a day. It was a dangerous working situation. And there were many deaths at that time just building the tunnels.
Ice brigades were formed to bring out exhausted workers to plunge them into ice water. But it was not enough. Frank Crowe had to react because the pace was too slow, despite working 7 days a week and 24 hours a day. He then invented a revolutionary machine, the drilling jumbo.
Drilling jumbo was a really ingenious thing. It was a 10-ton flatbed truck. And on the flatbed of this truck, they built platforms. They mounted on those platforms 25 to 31 individual drills. So they could take this truck and back it up to the bare rock face, and you've got 31 drills working at the same time, drilling holes.
They drill the holes 5, 8 feet deep. Then they pack each hole with dynamite. So you could put a stick of dynamite a foot. So you get 5 sticks in each hole. Being careful not to ignite any sticks. No smoking.
This giant drilling machine allowed a spectacular advance. In 24 hours, they were able to dig 260 feet of tunnel. The pace was so fast that they managed to dig 1.2 miles in a month. A record. In total, 1,600 tons of dynamite were used. The time saved was considerable, and the tunnels were completed 10 months ahead of schedule. But the human cost was very high. Due to the lack of ventilation in the tunnels, a lot of men working on the jumbos died of asphyxiation.
So you have all this carbon monoxide building up inside this confined space. You have the noise of the blasting. You have things dropping off of the ceiling, and maybe could hit you.
Even with the difficult working conditions, there was still a line of people waiting for their chance to get one of those jobs.
Engineers harbored a deep apprehension regarding one specific issue: flash floods, caused by heavy and unpredictable rainfall. The fluctuating flow of the river, combined with the narrowness of the canyon, increases the risk of water rising in the tunnels.
All at river level, which is a part of why it was so risky in case there had been a big flood.
There is a kind of rainy season that takes place mostly in summer, with extremely violent and very localized storms. This is what causes flash floods.
They did avoid one of those enormous Colorado River floods, fortunately, but there was a small flood. It did damage the construction site, and it did cause a minor delay.
Simultaneously with the construction of the tunnels, cofferdams were erected. The role of these temporary dams were to protect the site and redirect the river into the diversion tunnels.
The first one is built upstream to contain the flow and direct it to our diversions. The second one is built downstream because when the water comes out of the tunnel, it could, in the event of a flood, raise the water level in the river and drown the construction site.
They built a bridge, and they took big trucks and started dumping rock off the bridge into the river. Just dumping load after load of rock. Day after day, week after week, dumping rock in the river. And eventually, when the cofferdam was completed, the water actually backed up and started to flow through the tunnels.
On November 14th, 1932, the entrance gates to the upstream tunnels were blown open and the water rushed in, changing the natural course of the Colorado River. In only 17 months, these men tamed the river. The workers could then access the riverbed and begin excavations to build what will become the largest dam in the world. The workers, already exhausted after a year of work, suffered physically and morally. Life on the construction site was not only hard during the day, diseases spread quickly in the camp. Here too, Frank Crowe had to react in order to keep his workforce.
For those first couple of years, it was absolute chaos around the dam site.
They decided to build a city to accommodate the workers.
They wanted a model future city to go with it to house the workers. So right up the hill from Hoover Dam, out of the desert, they built Boulder City.
Initially, the city had to be built before construction of the dam began. But President Hoover was impatient and wanted the construction of the dam to begin earlier. Boulder City, a reference to the official name of the dam at the time, a new model of a man-made working-class city, was built late. 12 miles away, the work was in full swing. Once the river has been diverted, the workers set up in the dry riverbed to dig, excavate, level out, and remove the mud. The challenge was to obtain the most stable and suitable soil to accommodate the wall's foundations and install a waterproofing membrane. Water was their worst enemy. No question of letting it pass under the concrete wall, which would weaken the building and make it collapse.
Now that's hard in a river like the Colorado. You got a river millions of years old and you're gonna dig all the rubble out?
They had to remove the superficial layers of bad soil in order to find the right quality of foundation and the right type of rock.
After reaching the bedrock, additional cleaning operations are carried out to ensure that the excavation is as clean as possible before the structure is built on top of it.
We always used to say, in the dam business, the way we describe it, they clean that rock with toothbrushes.
The walls of the canyon were being leveled in preparation for the construction of the dam's concrete arch. The technical feat was human. Rope access technicians suspended above the void, armed with jackhammers and chisels, smooth out the walls so that there are no rough edges. The goal was to reach the most pristine and reliable rocks to support the dam wall.
In order to secure a part of the construction site, it was necessary to rappel down the canyon walls.
They actually hung over the side of the canyon, 700 feet above. They would put themselves in that chair and they would be carrying the drill or the pry bar or whatever piece of equipment they needed, and they would just jump over the canyon, and the only thing between them and death was a rope.
They had to get rid of all of that to get to pure, solid, smooth rock all around the canyon.
They would drill in, they'd set the dynamite, tamp it in, swing away, blow it off, then they'd come back with their pry bar and they'd be prying off the broken rock down, and it'd fall down and sometimes hit someone down there and sometimes not. It was dramatic.
After cleaning the surfaces, a waterproofing membrane was installed into the rock foundations by injecting cement and aggregates over 325 feet below the site and into each canyon wall. The workers were under pressure. Not even the slightest trickle of water must seep in at this stage of the project.
That took 6 months to clear out all the sand and muck and get down to hard rock, good for pouring concrete.
And that, of course, was going to take lots and lots and lots of concrete.
All of that is just solid, massive concrete.
Now that Frank Crowe and his 6 companies were ready to build the wall, the question of where to find the massive amount of concrete they need arose. They realized that it would have to be produced on site. To do so, they transported the necessary materials via rail lines from all over the United States to Boulder City, where the country's largest aggregate plant was being constructed. This facility was capable of producing an astounding 16 tons of aggregate every minute, which was then transported to on-site concrete plants.
2 on-site concrete plants were established to reduce transportation time and increase efficiency.
So that way they could mix the concrete at both the bottom of the canyon and the top of the canyon. Those went all the time.
The concrete for Hoover Dam is 3.25 million cubic yards.
To provide an idea of the scale of the project, the amount of concrete used to construct the dam is estimated to be enough to build a road 3 feet wide, encircling the Earth's equator. We're talking about truly pharaonic quantities.
Pouring that much concrete for a huge dam has its own challenges.
But when the ingredients of concrete mix, there is a reaction that produces heat that must be expelled.
The reaction that causes hardening of concrete is an exothermic reaction. The temperature inside the concrete can go up to 140 degrees, which provokes what is called a desiccation reaction, a drying reaction. This can lead to cracking the concrete. So it's important during the setting of the concrete to control its temperature to prevent excessive heat production.
Given the ambient heat of the desert, cooling the astronomical quantities of concrete required for the construction of the dam was almost impossible. On the other hand, if the concrete did not dry fast enough, it could weaken the solidity of the wall and ultimately compromise the integrity of the dam. The engineers had to ensure that the concrete set quickly.
Some people say that if they had just poured all concrete at one time for Hoover Dam, it would have taken over 120 years to fully cool.
Under pressure and driven by his obsession with meeting deadlines, Frank Crowe displayed his inventiveness once again. To prevent future cracks and ensure proper cooling and drying of the concrete, he opted to pour millions of cubic meters of concrete in autonomous squares, in carefully planned stages.
The idea was to break the dam up into many different blocks of concrete. And the blocks are huge. The blocks can be 20 feet by 10 feet tall by 20 feet wide. So 20 by 20 by 10.
After breaking down the wall into many small bricks, the cooling and setting time can be reduced. Another advantage of these small bricks is that by connecting them together with mortar, the wall's strength can be reinforced, thereby avoiding any risks of weakening due to water pressure on the concrete wall. There's a total of 215 bricks, and a system similar to a carnival game claw that has been invented to fill them. This involves an articulated arm that picks up the concrete and releases just the right amount into each small brick.
So he contrived a series of 10 high lines, where on one side of the canyon at the top was a head tower, and on the Arizona side was another tower that was stationary, didn't move.
That cable can lift 25 tons of concrete. So the beauty of that is you can roll the cableway across the canyon. And when you roll the cableway across the canyon, you can put the bucket where you want it. But then you could only pour the dam on one line. And we already said this dam is 2 football fields wide at the base. Well, they put one end of the cableway on a railroad. So now they could move it upstream and downstream and across the canyon. If you can move across the canyon and upstream and downstream, you can hit any spot with a bucket. And they were pouring a bucket every 3 minutes in the height of construction. This was production.
It was a very sophisticated network of these cableway cranes. Some people described it as a symphony.
That really sped things up.
Thanks to this ingenious process, 280,000 cubic feet of concrete were poured each day. And to accelerate the setting of the concrete, a network of 620 miles of pipes carrying cold water was integrated inside each block to cool the concrete even more rapidly.
The world's biggest refrigeration plant that generated ice water ran through tubes through each of those 5-foot blocks to quickly cool the concrete.
In fact, a kind of giant air conditioning system is installed inside the dam wall with coils through which cold water is circulated.
The tubes ran up and down the entire dam and greatly sped up the cooling and solid curing of the dam.
The construction of the wall was the largest operation of the construction site. It was also the riskiest, and a race against time to dry the concrete, a guarantee of the solidity of the structure. It was the first time in the history of civil engineering that such a large quantity of concrete was poured in such a short period of time. In less than 2 years, the dam was erected in the Black Canyon. The weight of the concrete on the canyon walls and ground would hold the structure of the dam in place. Frank Crowe could now focus on the second part of his mission, to produce electricity. The engineers then designed an innovative network of penstocks, a system of pipes transporting water from one point to another, which would transform this dam into a hydroelectric power plant.
To get the water into the penstocks and to the power plant at the bottom, intake towers were built out in the lake. 4 intake towers, 2 on each side, very similar idea to the diversion tunnels.
Intake towers are the inlets for the water from the lake to flow into the large pipes that feed generating units.
Well, those intake towers were fantastic engineering achievements. Each one 400 feet high, perched on the side of the canyon 300 feet above the river base.
The purpose of the intake towers is sometimes also to manage water quality, meaning that they are designed to avoid taking surface water which may be too warm, or water from deeper levels which may be too turbid due to high levels of suspended materials. Thus, the towers allow engineers to access the desired level of water.
The genius of the Hoover design is they reused 2 diversion tunnels to put the steel pipe in to carry pressurized water to the units.
The water enters the towers. It then travels through the old diversion tunnels at a speed of 87 miles per hour. It is diverted by the penstocks to the turbines of the power plant located 590 feet below.
The Hoover Dam power plant is at the base of the dam on the downstream side, up against the canyon walls on both sides.
The power plant adds another 600 feet or 2 soccer fields to that thickness of the dam. There's a power plant on each side of the river, one in Nevada, one in Arizona. The one in Nevada has 8 units. They're all about the same size. And the one in Arizona has 9 units.
When you visit Hoover Dam, you'll notice what appears to be gravel on top of those buildings at the bottom of the canyon. In fact, that's over 3 feet thick of gravel and rock on top of the concrete roof. The canyon is still active today. Every time it rains, rocks still fall into the canyon and hit that roof. It's a big cushion.
In 1935, everything was ready. It was the moment of truth, the moment of filling the reservoir. The engineers on the site hold their breath. A first steel gate closes at the entrance of the diversion tunnel on the Arizona side, allowing water to accumulate at the base of the intakes. Then, the second tunnel on the Nevada side is closed. At the beginning of the 20th century, these men were pioneers, working on the largest dam in the world. Despite their calculations, anything can happen when it's the first time.
That's an exciting moment. You close off the diversions and take the coffer dam down, let the water start piling up against the lake. It's a river upstream, though. That's a real important point.
One must imagine that until then, the structure has retained almost nothing but its own weight, and suddenly, within a few weeks, it will be asked to hold back a water column of 320 to 500 feet.
At that time, projects of this scale had never been undertaken before. And if something goes wrong, it would be a catastrophe.
For Frank Crowe, I don't think there was a feeling of risk because he's a perfectionist. He's driven.
In February 1935, there was a palpable sense of anxiety as the water began to accumulate. But the gamble of casting the concrete in sections paid off, and the Hoover Dam held strong. Gradually, Lake Mead formed upstream of the dam over a distance of 110 miles, becoming the largest lake in the United States.
It created the largest man-made reservoir on Earth. It broke all those records.
It's 247 square miles, roughly 6 times the size of Paris. It's larger than Lake Geneva, so it's really massive. And because of its massive size, it took 6 years for the lake to completely fill up. It took that long for the water from the Colorado River to accumulate and rise up behind that wall.
Lake Mead has 550 miles of shoreline, and it will dramatically change the geography of the region, creating an oasis in the middle of the desert.
A purpose of a reservoir like this is to contain water to be used at different times rather than to be dependent on nature and floods and droughts and things like that. It's sort of like a bank account, if you will, where you keep water and you can disperse it when you need it.
The project, originally planned to take 7 years, was completed in 1936. Frank Crowe proudly delivered the Hoover Dam in just 5 years, 2 years ahead of schedule, and received a bonus for his achievement. The budget was also managed with a $15 million saving. It was an impressive achievement, but it came at a high cost. Over 100 fatalities, accidents, and extremely difficult working conditions.
The heroism. The society treated the builder as a hero.
Franklin Roosevelt dedicated the dam, and it was the culmination of one of the greatest engineering projects that the United States had undertaken to that point.
It's an incredible media event. It's estimated that around 10,000 spectators came to witness the inauguration.
There were a line of cars that stretched from Hoover Dam all the way through Boulder City.
And it truly is a symbol of American power, economic recovery, and a brighter future.
It was the apotheosis of what people could do, and they did it, and they felt that they had accomplished something far more important than just a dam in a canyon. Man could control nature.
When Hoover Dam was built, it was the energy source for the Southwest. So Hoover Dam was the center of the world.
As Lake Mead filled up, the turbines got ready to generate the first kilowatts of electricity for the region.
The idea is we have to convert pressure and flow of water into electricity.
The water comes in from the canyon wall through the penstocks into the power plant to each generator. The generators have a water wheel attached to a shaft that goes up to the generator.
All we have to do is spin a generator with pressure and flow.
The generators of the Hoover Dam, powered by Francis turbines, were the largest of their time. These vertical hydraulic turbines allowed water to enter with high pressure and transmit its energy to the rotor blades.
The original capacity of the Hoover Dam power plant was about 1,300 megawatts. And in 1980s, they upgraded and put in bigger generators to bring it up to the 2,000 megawatt rating.
At the foot of the dam, there are massive high-voltage power lines that serve both southern Nevada and northern Arizona, making it one of the largest providers of hydroelectricity for a basin of around 40 million inhabitants: Arizona, Nevada, and California.
The transformation of the Hoover Dam into a power station was planned to make the construction of the dam profitable. This incredible gamble would become a model on a global scale. Today, 50% of the electricity produced is intended for the many cities of California around Los Angeles, and the rest is intended for Arizona and Nevada.
Power from Hoover Dam allowed for the Las Vegas Strip and all those lights that everybody recognizes around the world.
Lake Mead, on the other hand, was intended to supply water for irrigation and domestic use to nearly 8 million people in California, Arizona, and Nevada. The population of Las Vegas has grown from 50,000 residents during the construction of the dam to over 2 million today.
About 90% of the water that goes to Las Vegas is from Lake Mead.
That adds a strategic and even vital dimension to this dam.
This gigantic concrete structure, built to last for eternity, fulfilled its purpose. In the 1930s, the Hoover Dam became the most powerful hydroelectric installation in the world. But at what cost? No one cared about environmental protection at the time. The efficiency of the technological feat remained the priority. However, the design of the dam was based on studies of the Colorado River when its flow was much more powerful. The misjudgment made in the last century is now yielding consequences.
It is considered that the southwestern United States has been in a chronic drought situation since the early 2000s. Now there's even talk of a mega drought to underscore its unprecedented scale in the history of climate records.
Climate change is causing a weakening of all the functions of the dam: drinking water, irrigation, and electricity production. The region is experiencing one of the driest periods in the past 1,200 years, and Lake Mead, artificially created by closing the diversion tunnel's gates, is drying up.
And right now, the level of the lake is as low as it's been from when it was filling up. In other words, it's never been lower since the dam was built. The lake is down in its volume below 25% of its volume.
We have a decrease of 180 feet compared to the normal filling level of the reservoir lake. This is visually apparent by large white bands along the lake, indicating where the water used to be. And every year, it's getting worse.
You can see where the lake should be, and it's way lower than it's supposed to be. It's a really striking image.
And you don't have to be an American or a local resident to be both fascinated and terrified by these landscapes that are becoming more and more established with each passing year.
The boat ramps are left high and dry.
Islands that weren't there before would form.
The lake water level drops by 12 inches every month. The scarcity of rainfall combined with constant water demands puts the future of the entire region in danger. And what if there simply isn't enough water? The major issue remains the management of this resource.
At the same time, we are facing a dwindling resource and increasing demand due to the rapid population growth of cities. So what will happen if Lake Mead disappears?
Lake Mead is directly dependent on the flow of the Colorado River, which itself is experiencing the consequences of drought and overuse. The flow of the Colorado River has decreased by 20% over the past century.
I wouldn't say it's drying up, but there are more demands on the river by humans and agriculture particularly.
All these consequences will disrupt the balance of water pressure and thus electricity production, and put the very operation of the Hoover Dam in jeopardy.
If the level of the lake reaches a point that it cannot go through the intake towers, no more electricity.
When it goes about 50 meters further down, it will reach what's called dead pool. And at that point, no more water can be passed through the dam at all. The turbines will not be able to generate electricity.
So 1 foot of height equates to certain megawatts, and it has been decreasing as Lake Mead has gone down. So today, the power plant rating is around 1,300 megawatts, almost back to its original power plant design.
We are currently experiencing almost a 50% decrease in electrical production at the Hoover Dam.
The other danger for the dam is the emergence of invasive species that have proliferated. This is the case with quagga mussels that infest Lake Mead.
These mussels come from rivers in Eastern Europe. They have been found in Lake Mead since the 2000s.
And quagga mussels can get on the bottom of boats, they can get in pipes and clog up pipes.
They mainly affect the cooling water systems. The lake water comes into pipes that are cold, and that helps cool bearings, it helps cool generators, it helps cool lots of systems, not just the generator.
And the engineers at Hoover Dam have figured out different treatments to keep them from being a problem.
The key thrust of that management is to kill the quagga mussels when they're young with ultraviolet. So we use energy systems to kill the baby quaggas, and their water systems stay fairly clean.
The consequences of climate change are affecting the very structure of the dam, linked to torrential and violent rains that can batter the structure. The return of the feared floods and surges can damage the dam itself and endanger the population.
So when the lake fills up, and if it should ever overflow, the dam has these two fantastic features called the spillways, one on either side, Arizona, Nevada. The entrance to the spillways are at the top of the dam at the lake. They drop down at an angle 700 feet back down to the original diversion tunnels. That's what the spillways are now connected to. Divert the river downstream to the rest of the Colorado River. That can handle a huge amount of water if there's ever a flood. It happened one time in the 80s. The lake actually did spill over through the spillways on downstream. And that was with the power plant running continuously maximum 24 hours a day.
Although the concrete was designed to last 1,000 years, recent fluctuations in temperature and heavy rainfall events can cause cracks and thus weaken the dam. The floodwater then becomes the major risk again.
In 1983, when there was flood, they had to release a huge amount of water. And that created a bunch of turbulence in the tunnels. The problem with that, it actually destroys the concrete.
The flood was so intense that the Colorado River swept away large chunks of concrete and rock. These blocks fell into the spillway exits, hitting the bend of the diversion tunnels. The consequences of this flood could have been catastrophic.
The entire lake would have drained through the old diversion channel.
That lasted for a summer, and everything survived.
Erosion, concrete wear, and infiltrations due to climate change are all threats that are taken into account daily by the authorities. The older the Hoover Dam gets, the more expensive it becomes. The imbalance between the costs for its security and its output raises the problem of its profitability. Dams are also a priority target for protection. Blowing up a dam would be a sure way for terrorists to cause a large-scale human catastrophe. In 2010, to prevent this frightening possibility, the authorities decided to protect the Hoover Dam by building a bridge, the Hoover Dam Bypass. To reduce traffic on the dam, which is now considered a high-risk area. This architectural masterpiece spans the Colorado River at a height of 900 feet and is 1,900 feet long. It is the 11th highest bridge in the world. After nearly 90 years since its inauguration, is the Hoover Dam, once the pride of America, becoming a giant with feet of clay, as useless as it is dangerous? What is the future of this magnificent dam? Fortunately, the architects considered the importance of the aesthetics of the structure from the beginning. With its Art Deco style, the Hoover Dam is open to visitors. A monument dedicated to the 112 workers who died during construction, and bronze statues make the dam an artistic achievement.
Tourism was considered from the very conception of the dam.
It also stood almost in itself as a work of modernist art.
It was designed as a tourist destination, not just as a technical structure, but also as an admirable attraction. This also contributed to the glorification of the American spirit and the architectural grandeur that could be given to a tool that might seem purely technical.
People come from all over the world. Hoover Dam has always been a tourist attraction, and it always will be.
I think Hoover Dam then is going to become more of an attraction, something that you go see because it's beautiful.
The Hoover Hydroelectric Dam remains a global benchmark. Despite its maintenance costs, its operation is not currently being questioned by the U.S. government. However, with the consequences of climate change and the scarcity of rain, its reservoir, Lake Mead, risks drying up. Will the Hoover Dam still be as effective, or will it stop functioning?
The main threat is the inability to generate electricity.
The worst case scenario is that Lake Mead, the reservoir behind the dam, the level declines to what they call dead pool.
Predictions are right now that the lake will drop perhaps as much as another 10 meters in the next year. It's a wake-up call for a lot of people, you know.
It is clear that there is a strong political will to maintain the Hoover Dam's function of generating hydroelectric power, which requires a reduction in water withdrawals. As a result, the chosen course of action is to decrease urban water usage to prioritize hydroelectricity production, even if all usages are interconnected.
Everything is being done to save the lake, and thereby save the dam and its operation.
Alternative solutions are being considered to safeguard electricity production. One idea is to cover Lake Mead with photovoltaic panels, taking advantage of the region's significant annual sunshine. Another proposal involves creating a new reservoir downstream of the dam to store water, which can be pumped using reversible turbines to generate electricity during peak periods.
Many dams have reversible turbines that can either generate energy by spinning water or pump water back upstream.
The idea is to reuse the same gallons of water again and again.
They could use excess nighttime power to pump water back into the dam and let it go through during daytime. That's been studied for decades. That same function could be with wind power or solar power.
Despite its current weaknesses, the Hoover Dam cannot afford to stop operating. It is crucial for the region, as the southwestern states rely on both its water and clean electricity production.
The media often talk a lot about solar and wind power. Hydroelectric power, on the other hand, is often overlooked. It should not be forgotten that it remains the world's primary renewable energy source. It's a controllable energy source that is extremely flexible. It does not require sunny or windy conditions, and it can stabilize thousands of megawatts on the grid within minutes by simply opening a few valves.
The idea that we make the energy at the exact same moment that people are using it is the facts. Hoover can move a unit 100 megawatts in a minute. 100 megawatts in a minute. This is really a fast ramp for responding to things like when the sun goes down, all these solar plants go down, something has to replace that power if the customers are using power, and they are.
Hoover Dam is an essential part of the picture of the growth of the Southwest. It's irreplaceable right now, especially considering the population growth in the area.
The pioneering ambition of the 1930s did not take into account a major risk for the future: the ecological boomerang effect. Today, nature is reclaiming its rightful place, which Frank Crowe and his engineers failed to anticipate.
There are two ways to look at the Hoover Dam. One way is through a lens that is critical of the United States. This view sees the dam as an example of American excess, unrealistic planning, irresponsible use of resources, and foolishness in choosing to live in the desert.
Now here we are 100 years down the road. Hoover Dam now stands as proof of man's hubris. We were so proud and thought we could do such things, and we did them. But in the end, what difference had it made? Now we're at the mercy of the nature that we tried to control.
Another perspective, viewed through a more optimistic lens, is to see this Hoover Dam as a symbol of how innovation and technology can adapt and evolve. It could also be seen as a place to reflect on alternative uses for water and to consider how to give a new life to these dams that have, to some extent, reached their limits.
The Hoover Dam is undoubtedly a marvel of engineering and a symbol of triumphant America. It transformed a barren and inhospitable region into an attractive and prosperous area in the western United States. However, that era has now come to an end. Humans must and will need to rethink their approach to construction by incorporating nature into their technical ambitions.